Our lesson for today is about plain and reinforced concrete slab. Concrete is the most widely used material worldwide for construction and has been for centuries. As society has progressed, so too have the building materials we use, and that has led to quite a bit of variety in terms of the types of concrete we now have available. The most common two are plain concrete and reinforced concrete, and which you use always depends on the project in question. Plain cement concrete PCC or concrete cement CC or binding concrete consists of cement, sand, aggregate coarse and fine, water and admixtures. Reinforced concrete, concrete into which steel is incorporated in such a way that the two materials work in resistant forces together. What is structural detail drawing? A structural drawing, a type of engineering drawing, is a plan or set of plans for how a building or other structure will be built. Structural drawings are generally prepared by registered professional structural engineers and informed by architectural drawings. They are primarily concerned with the load-carrying members of a structure. They outline the size and types of materials to be used, as well as the general demands for connections. They do not address architectural details like surface finishes, partition walls, or mechanical systems. The structural drawings communicate the design of the building's structure to the building authority to review. Structural drawings would typically include the following information: north point, setting out dimensions for the concrete structure on site, plans, sections and elevations showing layout, dimensions and levels of all concrete members within the structure, location of all holes, chases, pockets, fixings, and other items affecting the concreting work, notes on specifications, finishes, and all cross-references affecting the construction. Provide the detailer with the layout and sectional information required to specify the length, shape, and number of each type of reinforcing bar. Plain concrete. Plain concrete is a brittle material with low tensile strain and strength capacities. The use of short, discontinuous fibers to strengthen and toughen such materials, which are much weaker in tension than in compression, goes back to ancient times. In modern times, the use of fibers to reinforce cementitious materials goes back to about 1900, when the invention of the Hatchek process enabled the production of asbestos cement. Over the past 40 years, there has been a steady increase in the use of fibers in cement and concrete. Today, about 100 million cubic meters of fiber-reinforced concrete are produced annually. Some of the uses of plain cement concrete are: it is commonly used in the construction of the column foundation, massive gravity dams, flooring, etc. It is used in rigid pavement construction reinforcement, less rigid pavement, in small-scale canal construction. PCC is used. It is also used in some stone masonry works. The advantages and disadvantages of plain concrete. Advantages: it is incredibly strong under compression whilst weak under tension. This means that when on a solid, unmoving surface, it is capable of withstanding huge amounts of weight. This makes it the perfect material for ground floor layers and providing a stable and even base for reinforced concrete to be built onto while limiting its use in larger construction projects. Disadvantage: however, when placed under tension, it is much weaker and can often crack and buckle. Reinforced concrete. Reinforced concrete slabs are used to provide structural floor support to a foundation. Concrete floor slabs are used in modern buildings to provide flat floors and ceilings. Reinforced concrete slabs are usually lightly reinforced because the span or depth ratios are normally governed by requirements of adequate stiffness to avoid excessive deflections. Hence, the sections generally have sufficient plastic rotation capacity to allow full moment distribution to take place at ultimate load. How to design a reinforced concrete slab. Each reinforcement concrete slab must go through a build process that is not complex, but must be strictly followed. Before even starting to make the concrete mix, the ground where the slab is to be placed must be prepared. You have to: first, remove all plant elements. Second, flatten the ground. If it is necessary to fill some part of the ground to level it in the lower parts, it is best to use calc, a type of sedimentary rock, because it is easy to compact. The upper parts are leveled by digging. This step is essential to make the slab completely flat. Third, find the right humidity level. If there is too much moisture, the ground will be a viscous mass, which will make the structure unstable. If there's too little moisture, the ground will be too wet, which will cause it to break up. Depending on the type of ground, the optimal moisture level must be found. Water must be added, or the ground must be aerated with the plow to raise or lower the moisture level. Fourth, compact the ground. After determining the areas where calc is to be used, the layers to be added must be very thin so that they can be compacted with rollers. Each new layer on top must be very thin, and then the roller is used until the desired level is reached. This process will give the ground stability. Doing all these steps in the correct order is important for the stability of the reinforcement concrete slab. After the ground is adequately prepared, the wooden mold must be made. Then, the steel beams with a diameter of 4 or 6 millimeters are placed inside, in the shape of a mesh. Between the beams, there can be 15x 15 centimeters or 15x 25 centimeters separation. The function of this mesh is to distribute the weight of the structure and to offer resistance against the cracks that could suffer the reinforcement concrete slab. The recommended thickness for each reinforcement concrete slab will vary depending on the desired resistance. Low resistance, suitable for people, 10-12 cm. Medium resistance, suitable for light vehicles, 13-15 cm. It is essential to make the reinforced concrete slab expansion joint. High resistance, suitable for heavy machinery, 16 or more cm. The advantages and disadvantages of reinforced concrete. Advantages: able to stand up to weight pushing down onto it, as well as any wind pressure or shifting that results in slight twists and strains. Thanks to the increased flexural capacity of the concrete or steel mix, it is the ideal material for taller and heavier buildings and for roads and bridges. Steel is the most common material used for the creation of rebar, as it reacts to very similar variances in temperature as concrete, meaning it will expand and contract with the concrete rather than cracking it from the inside. Disadvantage: one of the major disadvantages of reinforced concrete is the lack of tensile strength. Though the concrete is strong in compression, it is very weak in tension. Therefore, usually, except on special occasions, the contribution of the tensile strength of concrete is not considered in the design. Difference between PCC and RC. The difference between PCC and RC are as follows. PCC, plain cement concrete. It doesn't include steel. PCC is weak in tension loading while strong in compression loading. PCC blasts on extreme loading and in an instant W or T, providing any notice. While RC, reinforced cement concrete, it includes steel. RC is strong in both. RC provides you sufficient time to get out of the structure before the collapse. One-way slab. One-way slab is a slab which is supported by beams on the two opposite sides to carry the load along one direction. The ratio of longer span L to shorter span B is equal or greater than 2, considered as one-way slab because the slab will bend in one direction, i.e. in the direction along its shorter span. Due to the huge difference in lengths, the load is not transferred to the shorter beams. Main reinforcement is provided in shorter span and distribution reinforcement in a longer. The structural action of a one-way slab can be visualized in terms of the deformed shape of the loaded surface. The deflected shape of a rectangular slab, simply supported along its two opposite long edges and free of any support along the two opposite short edges, is shown in Figure 1. The deflected shape is shown by solid lines, bending moments are the same in all strips as spanning in a short direction between supported edges, whereas there is no bending moment in the long strips L parallel to the supported edges. The surface is approximately cylindrical. Two-way slab. Two-way slab is a slab supported by beams on all the four sides, and the loads are carried by the supports along with both directions. It is known as two-way slab. In two-way slab, the ratio of longer span L to shorter span B is less than 2. In two-way slabs, the load will be carried in both the directions. So, the main reinforcement is provided in both directions for two-way slabs. Example: these types of slabs are used in constructing floors of a multi-storied building. How to differentiate one-way slab from two-way slab? When a rectangular slab is supported on all four sides, but the ratio of the longer side L to the shorter side S is 2 or more liter per second to 0.0, then the slab will act as a one-way slab with bending primarily occurring in the short direction. When the slab is supported on only two sides, the load will be transferred to these sides regardless of its ratio of longer span to shorter span, and it will be classified as a one-way slab. To measure your understanding about the topic, I provided an activity for you to answer. Good luck! Thank you for listening.